Now, so that leads us into talking about one and two-sided limits here. The limit is, how a function behaves as you get close to that. So that graph is it's actually on my website if you want to play around with this graph. One and two-sided limits, so it looks like that. I think it's the same. Yeah, it's the same. So you follow this little red point here. It's following along this function here. As you get close to this value, -1. So as x is getting close, so this blue slider, as I get close to -1 here, how does that function behave? As I get close from the left, the y values are zeroing in on 1. Whereas as I approach -1 from the right, they're 2. Okay? When we're talking about here, when we're talking about approaching -1, from the right, the function's zoning in on 2. From the left, it's heading for 1. Since those are different, since it's headed for different things from different sides, there's no limit at that point. There's a right-hand limit, which is 2. There's a left-hand limit, which is 1. But there's no limit, which is to call a two-sided limit here. So let's look at this in here. Maybe we can put both of these together again. We could have both at once. Move that over slightly a bit more. If we're going to look at the limit as you approach, maybe we should have stuck with the positive numbers here. As I approach 1, okay, as this value approaches 1 here, from the left, this is headed for 2. The way you write that here is you say, you put a little plus or minus sign after the number to say which side you're coming from. So when you're coming from the right side of 1, okay, this value here, 1. When you're coming from the right side of 1, you say x approaches 1 from the positive side. That's what that means. You say limit as x approaches 1 plus. It means, 1 plus. Okay, this means 1 from the positive side. The right side's the positive side, that direction. As you approach 1 from the positive side, that's headed for 0. As you approach 1 from the negative side, this function is headed for 2. It's 2 the whole way. It's not even headed for 2. Since these are different, since the right-hand limit and the left-hand limit, okay, this is from the right. Okay, this is approaching 1 from the right, and this is 1 from the left. This doesn't exist. Okay, since the two sides don't agree, you can't say there's a limit at 1. You can say there's a left and a right, but not a two-sided limit. As you approach 0 here, okay, as you approach 0, from the right, I'm headed for 2, and from the left, I'm headed for 2. It's actually defined at 0, right? It's headed for the same number from either side, so that limit does exist, that two-sided limit. It's 2, because it's headed for the same value from either side. And if you look at 2 here, 2 from the positive side and 2 from the negative side. Back to this. Okay, so approaching 2 from the positive side looks like you're headed for -1. It's -1 the whole time. Whereas if you're going 2 from the negative side, you're going for 1. This is going for -1. This goes for +1. So then again, this does not exist. -1 from the positive side. We looked at that one before. Here's -1. As you approach -1 from the positive side, that limit is 2. because that's how the function's behaving as you come from that side. Alright, you try this one, and you try this one. You can look at a graph of this and try and decide some of those things. Alright, and then I think we're good. If you graph this on your calculator, y1 equals int x. It gives you this greatest integer function. Play around and see what this means. It's the greatest integer to the left of the one you're looking at. Greatest integer of 2.3 is 2. Okay, the greatest integer to the left of that number. Greatest integer of 2.9 is 2. Greatest integer of 3 is 3. And so on. So you're going to graph this function and see what it looks like on your calculator. Depending on the calculator you have, it might graph it properly, it might graph it in a kind of a crazy way. If you want to find it, I think it's under this integer part of x. Again, if it's not already on that, do zoom decimal. Now, it's not supposed to draw these vertical lines here. It's supposed to be steps. It's supposed to be just horizontal lines. A function doesn't have those vertical lines there. So when you're drawing it, it's just greatest integer of 0 is 0. Greatest integer of any number up to 1 there. Below 1 is 0. As soon as you get to 1, this is 1 now. And it looks like that. And it looks like that. Okay. Have a look. This is actually in the textbook if you want to check. And like that. Alright. As you're heading for any integer value, the limits, okay, as you approach 1 from the negative side, 1 from the positive side, you're going to run into problems, right? Because the limit's going to be different. If you're headed for this point, 0.6 right here, whether you come from the right or the left, it's headed for the same value. So its two-sided limit exists, it's 0. If you want to know what limit of, as you approach 1.5, well, here's 1.5. As you come from either side, it agrees. When you're headed for 1, though, you have problems. Anyways, what I would like you to do is start working on your assignment for that section, for this section, 2.1. Thursday, we're going to look at limits involving infinity. You could actually start working on this too if you want, but you can safely leave it for next day and work on some of the assignment. All right.